Okay. Um, so last time looks like, people did a lot of homework. This is a great news. Really, the only way to be good at it is doing, the work and yourself. And let me, you know, um, go through the problems that, we need to go through more. So this one is actually Pythagorean theorem problem in disguise. It is a rectangular prism, and so if we just do the like, um, so 3D problem always trying to do a shadow, like shine the light ray. If you shine the ray back forth, this way, what you will get, it will project a shadow like this. And this is the bottom of the tip. And this is 30°. And this is parallel. This is horizontal supposedly. So it will map here to be 30° also. And this is a rectangular face. So this has a 90°. So this is a right triangle. Given the right triangle, we know that this is a rectangle. So the 6" will translate all the way here. So this is 6. And this is like a 30, 60, and a 90° triangle. What we got is that this is the short leg is 1, long leg is square root of 3, and the hypotenuse is 2. So given those information, um, we will be able to find out this leg. So this leg is what we are going after. So 1 over square root of 3. And the ratio problem best is done by, explicitly naming the ratio. For here, we are doing the short leg over the long leg. So basically in this right triangle, so 1 over 3 equal to, I will say that you can say x over 6, because this is the 6, which translated from here. Then basically, we want to factor out the square root of 3. So basically we can do 2 multiply square root of 3, then square root of 3. So in this case, in order to, so if I put 1 here, so the other thing that the x supposedly will be 2 square root of 3 in order for this to work. For the rest will cancel, and it is 1 over square root of 3. So x is this number. And 1x is 2 square root of 3. We kind of just multiply it. And this is this side is multiply 6. Then this treated as the base for a triangular prism. So the base is, this is a triangular shape. So basically, this area is in this format. So the base in this, so the surface area of this triangle is 6 square root of 3. Then, how long this prism is, it's 6, because it is 6 translated here. So 6 multiplied 6 square root of 3 equals 36 square root of 3. I think that's the answer. Let me just check my previous work. I know I done it right. So yeah, this is the cube. So basically the area is 30. And don't forget the unit is inch cube. And then the second question is that the diagonal of right trapezoid are perpendicular. What is the area of the trapezoid if parallel base measure 8 cm and 18 cm? In this problem, basically we have to construct a right triangle or right trapezoid. Right trapezoid has the, like this side has a right, and then the diagonal is also right. So this is also right. And this is the 8. This is the 18. So basically when you're doing the right triangle, especially in this setting, you have, you know, basically this is the height of this right triangle. So basically, you know, always looking for this. And if you have a height on the hypotenuse, so this basically is the height on the hypotenuse. You have three similar triangles. So let me label all those three. And so this is the small one, and this is similar to this. The yellow one then is also similar to the whole thing. So those are similar. Then if you're looking at the other way, so this is the way that testing your skill on doing the triangles. So here, basically we have another right triangle, you know, with height on the hypotenuse here. Hypotenuse is the diagonal. So basically we have this is similar to this and also similar to the whole thing. So basically, you know, those are similar. And those are similar. Then basically we have this whole thing is similar to this whole thing because both big triangle are similar to this yellow triangle. So similarity has like, you know, the transferation relationship. So basically, you know, there's a relationship between, you know, the smaller big triangle, including the top base, and the big triangle, including the bottom base. And their similarity is established through the yellow triangle, which we can tell. And so basically, for the right triangle, the easiest way to establish the relationship between the legs are you can use short leg and long leg and hypotenuse. And those always will going to work. So what we know that from the top triangle, basically this is short leg, this is long leg, and this is the hypotenuse. And for here, basically we have the short leg and long leg and the hypotenuse. So obviously, you know, what we already know is that here, this side and this side. And basically the short leg, long leg, short leg, long leg. So basically this height, the height is what we really want to get. And this linked together with a ratio between them. So this is the key we want to observe. So basically we can short leg over long leg is equal to 8 over height and equals height over 18. So basically is the height square going to be equal to, I usually don't multiply them, I just factor them. So basically it's actually 4 multiply 2 multiply 2 multiply 9. So basically I can even factor them more. So this is 4 square multiply 3 square. So obviously h will be equal to 12. So after you get h equals 12, then it's very easy to calculate the area. The area is the average. Every area is the length of the mesh segment or median for the trapezoid. So it's average of top and bottom. And when you average them, it's just 4 plus 9 equals 13. So 13 is their median. And multiply 12, 26, 13, and 156. So this is the area of the whole thing. Let's check. Yeah, I'm on this problem, I'm using an algebraic method, but you know, there are 2 methods doing this. I'm going to just show a simple one. And so this one is a, you know, also a very nice problem. So this one basically, we need to find out the relationship between those centers. Usually when you see circle and semicircle, always add a center. That's the key to solve this problem. If you connect the center of those semi-triangle or semi-circle, basically, these are tangent point for the congruent semicircles. So basically, if this is a radius here, and this is also radius. So these are all the radius. And the side length is 1. So basically here is 1. And then what we trying to see is trying to express the combined area. So the outside square is 1 square. We kind of just have to or combined area, we basically need to find out R. R, we absolutely need to find it out. And the R, how do we find out R? We know that, the side length of the square made up of R on the top. Then here basically is R, and this is a right triangle, this is 2R. So the short leg over the hypotenuse is actually 1/2. So this is a 60-degree angle. 60-degree angle, basically we have, the leg hypotenuse relationship is 1 over square root of 2 over d2. So basically that's the relationship. So this is 1 here, and this part is going to be square root of 3r. So basically what we got is that, so on the top is r, on the bottom is square root of 3r. So and those add together are going to be 1. So basically we got 1 plus r plus square root of 3r equal to 1. And r going to be 1 divided by square root of 3 plus 1. And we kind of can rationalize the denominator. Then so basically we multiply, and we multiply square root of 3 minus 1 on both numerator and denominator. And we will get, this is 3 minus 1 on the bottom, on the top is just square root of 3 minus 1, and this is going to be square root of 3 over 2 minus and 1 over 2. So that's the R. R is this, and basically we basically have 4 semicircle, and for semicircle, basically, the area of combined shaded area going to be 2 multiply pi r square. 2 is just, combine 2 semicircle going to be 2 full circle. So that's what it is. And then the r square, we just have to multiply, square this. And it's just square, it's going to be 3/4 and plus 1/4 minus 2 square root of 3 over 2 multiply 1 over 2. And we cancel out this. And this is r square and pi. And this is in the parentheses and also has a 2 outside. So here basically, it's just 1 to pi multiply 1 and minus and square root of 3 over 2. So that should be the answer. And you can multiply into it and whatever. So basically that's, yeah, I kind of just multiply it out. It's still the same. Basically, it didn't, even you stop at this step, it's still right. So the whole thing is just this way. Okay. So this one is another problem that kind of, challenging. And did I start recording? I may not have started recording yet, I think. Yeah, it's recording. So what is the area of the largest semicircle which can be inscribed within the rhombus? So the largest semicircle, you kind of just have to imagine it. You know, you can do some certain experiment. It's the key is semicircle. It's not a full circle. Basically, I just inscribe semicircle. So if you do it this orientation, obviously it's a full circle, which is not as big. But if you're trying to put a line here, and if you put the diameter of the semicircle here and try to inscribe in this direction, it actually could end up in bigger shape. So basically, let's do it this way. And after doing it this way, because of the symmetry, basically I am, you know, for this side basically we are basically bisecting the 120 angle. So basically this here is going to be a 30, 60, and 90 angle. So here, let's assume, so in this triangle, let's assume this side is x. Then basically the radius of the semicircle going to be square root of 3x. Then you can also do it here. And because that's 3 centimeter, so the side of the rhombus is 3. And because this is a 60-degree A, so basically this BD going to be also 3. So BD equal to 3 because this is equilateral triangle. And so what left? So if I do it this way, then here is, let's say, A, B, C, D. Let's say this is E, F, and G. Then basically, you know, BG or BG going to be BD minus DG equal to 3 minus DG. DG is just the X, what we assume. So basically this is the BG. This part is 3 minus X. And this basically will form another triangle. So this triangle, in this triangle, basically the radius going to be 3 square root of 3x. So square root of 3x and this is BG. BG is 3 minus x is actually equal to going to be 3 square root of 3 over 2, because this is basically is a 30, 60, 90 degree triangle. It's going to be, the leg ratio is 1 square root of 3 and 2. So by doing this way, we actually make an equation. And what we can do is trying to multiply it out. This is 2 square root of, we do cross multiplication, 2 square root of 3x equal to 3 square root of 3 minus square root of 3x. And so basically here, we plus square root of 3x on both sides. We got 3 square root of 3x equals 3 square root of 3, and x will be equal to 1. So x equal to 1, and the radius going to be square root of 3 multiply 1 equal to square root of 3. So the radius for the inscribed semicircle going to be square root of 3, and it's trying to, what is the area of the largest? So we're going to calculate its area. The area is just 1/2 pi r square equal to 1/2 pi multiply square root of 3 and square equal to 32 pi and cm square. So this is the final result. Let's check if I did it right this time. 3/2 pi. Yeah, 3/2 pi. So basically that's the, and so this one basically, we have a two circle, have some distance, and what we are trying to do is calculate the, length of this tangent CD, this tangent to both circle. And with tangent, you absolutely have to draw the radius to the tangent point. So that's very important. If you draw that, because of these are right, and this is the vertical angle. So we actually got a similar triangle. Let's say this is X. So ACX going to be similar to BDX. And so we know that the length, the distance between their circles, so AB going to be equal to 90. And so and radius one is, A is 28 and this is 44. So this is 44, this is 28. What we can do is expand it this way, just extend this radius and also draw a parallel line. So this basically will make a rectangle here. This will translate this 28 from this radius to this side. So this is 28. And this is AB is still 90. 90 between AB and this is, because it's a rectangle, so we create a bigger right triangle with hypotenuse equals 90 and one of the leg is equal to, so leg one going to be 44 plus 28 going to be equal to 72. So basically, we will, so we're trying to find leg two. So leg two basically, will be the, so it looks like they have awful lot of the similar or like common factors. So usually in this situation, we will try to factor it. And trying to factor it, you can say it's 9 multiplied 10 equal to 3 square multiplied 2 multiplied 5. And this going to be 8 multiplied 9 going to be like 3 square multiplied 2. I already saw a 2, so I just put a 2, then multiply 4. So basically this is the common factor, and this is a 5, 4. And 5 is happen to be hypotenuse. So hypotenuse and leg 1 is 5 and 4. The leg 2 must be 3, like 3 square multiplied 2 multiply 3. So that's fairly obvious to, so this going to be 9, this going to be 6. So 9 multiplied 6 equal to 54. So that's going to be the answer. And let's check. Yeah, I think it's 54. It's the right answer. So there's 1 and a square. So this one is still, the trick of trying to do all the like right triangles, because right triangle is the key to solve this type of problem. They're trying to find where the diameter is, because it's trying to find what is the diameter of this circle. And diameters of circle, obviously you can find it here. This is one way, but it's really hard to find. There's another way is that, you know, if we do it this way, we can also find the diameter. So this is diameter 1, diameter 2, diameter 3. And diameter 1 and diameter 2, we have a right triangle here because this is the rectangle. So we know that it is. And but those are, this side is easy to calculate, but this side is extremely difficult to calculate. So what we are trying to do is that, like, you know, for this side, this is actually easier to calculate. So basically, if we create this right triangle, then basically it's easy to calculate. And this right triangle basically, you know, has good property because this side, we actually know the length. So this is 2 and 4. And because this is a typical right triangle, because it's a inscribed, if it's inscribed on the semicircle, this is right. So this is 1 and 2, because this is 2, 4 and 1, 2. So basically, given those information, we can see that, you know, it's actually diameter is just 1 plus 4 equal to 5. So you will be able to solve this problem easily using the similar triangle in the, so this one we actually talk about this in the class, and obviously this is a very difficult one, and it's not so obvious. So if the key is that you have to do this on this way, because you know that, you know, basically if you cut the semi-sphere this diagonally, it's actually will, because the tip of this is inscribed. Inscribed means that the extremity of this shape going to touch the sphere face. Extremity of this cube is the tip. So basically, if you cut the sphere this way, we actually will see the semicircle, and also this way. And so this going to be just coincide with the 2-inch edge. And this, because it's diagonal, so this will not be 2. It's going to be a 2 square root of 2. So we half of it from here. This is going to be pass through right the center, going to be square root of 2. So basically, we are able to use this shape to find out the radius of this semi-sphere. So it's going to be square root of 2 square plus 2 square and square root. That's the, we're going to find the, so this is going to be 4 plus 2 square root equals square root of 6. So the, basically, if you do it this way, the radius of this semi-sphere going to be square root of 6. And the surface area of the whole sphere is actually 4 pi r square. So the surface area of the half is going to be, half sphere going to be 2 pi r square equal to 2 pi multiply, so r squared is just 6, so this is the top, and the bottom is just pi r square because it's a flat surface, so that's going to be pi multiply 6. So if you add them together, it's going to be 18 pi. So 18 pi is the total surface area of this hemisphere.
Okay.
And so let's see, this one is that there are two cylinders are partially filled with water, each to the depth of, so you kind of is able to draw the like, you know, one is slimmer, the other is more thick. And so this going to be 3, the radius, the other is radius 4, and depth is 24. So basically they are quite deep. And let's say fill to here. And right now they are filled to both 24. Obviously it's not drawn to the scale, but it just looks like this way. And so eventually they will hold equal volume of the water. So the best way is try to calculate the total volume of the both cylinder first. And the total volume of both cylinder is actually equal to pi r square multiply h1 plus pi r square these are R1, R2, and h2 square. And so they are both 24. So right now it's actually, you know, we can actually factor those out. So basically pi multiply 24 multiply R1 is just 3 square plus 4 square. So that's going to be like pi multiply 24 multiply 25. So when you see this type of thing, usually it's best to make 4 and trying to do it. So it's pi multiply 4 multiply 6 multiply 25. We know 4 multiply 25 going to be make 100, and this is 6. So basically it's going to be 600 pi. And 600 pi is the volume of both, you know, all the waters containing both cylinders. So, you know, in order to even the water volume between those two cylinders, each cylinder should have 300 pi like cubical feet. So basically, we going to, like, you know, use this volume as a target to find the depths of cylinder 1 and the cylinder 2, then do a minus. So it's very straightforward calculation. So basically it's the pi multiply 3 square multiply h1 going to be 300 pi, and we cancel out pi, and this going to be h1 going to be 300 divided by 9 equal to 3 multiply 100 and 3 multiply 3. So it's going to be simplified to 100 over 3. And the h, then the second one is basically pi multiply 4 square multiply h2 going to be 300 pi. And we cancel out, and so basically we're going to get h2 going to be 300 over 4 square. So 4 multiply 4. And here on the top, we can easily factor out 3 multiply 4 multiply 25. So basically we cancel out one of the 4. It's going to be actually 75. So 75 over 4. So calculate the height difference between those two cylinders is quite simple. It is like 300 over 9 minus 75 over 4. actually 3, it's 100 over 3. So because we already simplify it. So basically you just find a common denominator. That's 12, 400 minus, this is going to 225. That's going to be, that's going to be 175 divided by 12. 175 divided by 12 going to be 12 and 55. That's going to be 48. That's going to be 7. That's going to be 14 and 14 feet and 7 inches. So basically that's the final. Okay, so right now we actually reached this point, and then let's go to the new topic today, and the new topic going to be the today we are going to go through the like counting, and counting is actually a very interesting topic. We have been doing a lot of counting class in the summer, and so this time we're going to like fast track it. So basically, it has a whole lot of content, but we simply don't have enough time since we already go through it once, and it's going to be not too difficult. So the first topic on the counting is that counting 1, 2, 3, and basically it's just, you know, it's actually a very simple thing is that, you know, exclusive counting and inclusive counting. So basically, you know, less than and greater than, that's exclusive. And this is than how uneven number, less than but greater than. So this is like a skip counting. Then we kind of just going to do those problems really quickly. Then start at, count by 5. So basically this is like, you know the starting point and try to get the end point. And so basically, you know, less than, greater than. So basically it's 600 minus 500. And because it's exclusive, not including 600 and not including 500. If it is including, it's +1. It's excluding, you just -1. And the even integers, basically, you know, we are for even integers less. So basically we cannot start with 500 and we cannot end with 600. We have to find a real number which start. So basically we start going with 502 and we'll end at 598. So basically we can do so usually inclusive counting is a better bet because inclusive you have a clear ending, a clear beginning. So that actually is able to fit the formula. Otherwise, if you use exclusive is usually when you're trying to do the exclusive, you can convert into inclusive first. For example, how many integers less than, you can convert this problem in 599 and the greater than, so you have to start 501. So you actually can convert those. So this you can 599 minus 501 plus 1. So this is another way of doing it. But on the second problem, you definitely have to convert it. So became inclusive counting. That's 598 minus 502. And because the gap, the even because you're doing skip counting, you divide by 2, then plus 1. So that's the way you really do this type of the problem. Okay, so I kind of will just, getting on to more of the problem. And so, um, so, um, um, so when you do exclude counting, you actually have to minus 1. And inclusive counting, you basically plus 1. When you do skip counting, you also have to like divide or be minus a divide by the like gap plus 1. And then there's a special case. You kind of just, especially in the test, you just have to remember this case. So, and if you are doing the post counting, so this is the post, and post counting basically, post counting is that the parameter of the whole thing is actually 60, because this is 30 plus 30, so 60. The parameter of this is 60. You just 60 divide by the 10. You actually will got 60. Yeah, 60 yard. So this is 60 yard. This is 30 yard. So basically, and they are doing like 3-yard post. Every 3 yard. So basically, in this case is actually 60 plus 30, then multiply 2 divided by 3. That will actually do the trick, because when you do the post counting, basically it's actually even out. There's no overcount. There's also no missing count. So basically, you will actually count the whole distance exactly once. So in the parameter, including the post counting, if the post distance is even, you just the parameter divided by the gap, you will get the whole post count. This is a special case. So we kind of get through the basics. Then we have to go through the Venn diagram. And the Venn diagram is a really fun thing. It's actually a Venn diagram. We kind of talk about the history. Let me talk about the history of the Venn diagram. The Venn actually has a name on it. So it's actually, you possibly will think about what is the Venn diagram? What does the Venn mean? Venn is actually a professor, in Cambridge University in England, and you called John Venn. And he developed this Venn diagram for us to use. And then the Venn diagram actually, obviously you have like one circle Venn and two circle and a three circle. So this is actually on the tinted glass of a church and inside Cambridge University. And on the glass, it's a tinted glass with the three category and Venn diagram. But Venn diagram has some limitations that can only go up to three. Then himself actually developed some Venn diagrams that, you know, all-shaped Venn diagram that are able to handle up to like maybe 5 or 6. But later on, there's another guy called Edward develop, you know, like Venn diagram, able to handle like more than 3. So this is the 3 category, the new Venn diagram. This is the 4 category diagram. This is 5, this is the 6. I think it's really, you know, I never saw a Venn diagram problem use 4 category, but if you know how to draw this, I think you pretty much is able to handle everything, because this is just an alternative for 3 category Venn diagram. You can draw it like, you know, including the circle. So this is the first category, and this is the second category, doing it this way. This is the intersection. So let's say that if it's a 2 category, if you're drawing this way, it's perfect. Basically, Venn diagram is each category. Adding a category just multiply the area by 2. For example, a 1 category Venn diagram, you can just draw a rectangle and then a square, and you know, one side is belong to it, the other side not belonging to it. Then a 2 category, if you draw like this, it's very, so this is none, this is 1, this is 2, this is both. So it's very easy to comprehend. Then for the 3 category, basically you will just, so basically it's starting from a different thing. It's not using a circle. It's for the first 2 dimension, it's just using a square almost. So basically you can draw it fairly easily. For the third dimension, basically, you know, it go to 3D, and so you kind of draw a big circle on it. So basically, you know, um, this will be, for example, this is the area. This is area not belonging to anyone. So this is none. And this is only belonging to the category 3. Then and this is category 1, category 2. This is only belong to category 1. This is only belonging category 1 and 3. So 1 and 3. This is belong to 2 and 3. And then this is belonging to 1 and 2 and 3. So basically that's the, and this is belonging to both 1 and 2, because this is, you know, if you this is none, this is 1, this is 2, this is 1 and 2. So here, if you really look at it, it's just 1 and 2. So basically this is, and this actually divides things into 8 area perfectly. Then using four category, you will just, you know, on the first two category going to be like a square based. Then the third going to be like a circle. Then the first you're going to draw like a semicircle here and a semicircle here. Then this is connecting them. It's almost, the curve is almost like the, you know, the tennis ball curve that occur on your tennis ball. So this will divide, you know, your area into 16. Basically, I just trying to count the area. So this is 1, 2, 3, 4. So basically, you know, in each quadrant, you have 4 area, 1, 2, 3, 4, and 1, 2, 3, 4, 1, 2, 3, 4. So this is a perfectly drawn like for category. And then the 5 category, you will just draw. So you are replacing each, when going to the, it's fairly symmetric. Going to the higher category, you're just replacing it with more semicircle. So basically, it's just, the first one is a full circle. The second one, you do the, just one direction half circle and try to connect it. Then 5 dimension, you kind of just draw the semicircle around the original circles and within the, so basically you are able to draw this and trying to connect them together. You are able to get, this is actually, 15, 5 category, 2 to the 5th area. So if you really draw it. So it's fairly easy to remember and fairly easy to draw. So thanks to, thanks to Van and John, we are able to handle, and this you're still going to be able to do it. It's just drawing smaller semicircles and connecting to it. So this basically you just draw even smaller semicircle on. So the circle start from the center, then going to semicircle in one direction, going so east west, then going four direction on smaller semicircle. So east, west, north, and south. Then if you get to 6th category, you just the semicircle you're going to draw on a direction. So northeast and east, southeast, south. So kind of just go around, you will be able to create. So this is a very, very advanced method. And but anyway, it just gave you more tools to handle the higher like Venn diagram. I'm not going to go through the detailed one. And I think we have been discussing Venn diagram before, and it's all about just filling in the area in the right way. And then we're going to go to this topic on the bowling pin and the handshakes. And the bowling pin, if you have ever been to the bowling ball alley, basically they will mechanically put all those bowling pin, and so you roll ball to knock them down, and the top one will face you. So to count them, basically it's starting from the first layer is 1, second layer 2, third layer 3, and it's 4. So it's actually just like trying to counting the arithmetic theory, and that's actually quite simple. And we're going to use 3 methods to count it. And so the first method, using the average. Using the average, the reason behind it is for any arithmetic theory, it's not just limit 1 to the n, anything. You actually can, do the average. Do the average of the first one, the last one, then multiply the number, the cardinality of the sample, you will get the total. So basically, like this is asking, considering you have 12 row of pin, and the first row is just 1, the last row is 12. say average is 6.5. So 6.5 is the average. And we're trying to find, do the row count. The row count is just 12. So if you multiply it, it's going to be 78. So this is an easy way to do the triangle number. Then the second method, I actually prefer the second method always because it's just, it's just double sum, reverse and double sum. So it's always like reverse and double sum. Reverse and double sum, basically, this is the original stack of the pin. And if you reverse them and trying to stack them together, then each row, each column will actually end up with like a fixed number. Then you actually n multiply n plus 1 divided by 2. You will get, the top is the count of double sum, then divided by 2 is just, you want to get a single sum. You actually will get this. I'm going to also emphasize on the third method. The third method is actually statistic method. It's actually convert a problem into handshaking problem. So basically, like so this is the bowling ball pin is adding up, and the handshake is just like, so if you have, a stack of 12 pin and 12 layer of the pin, equivalently, it actually is equal to the number of the handshake by 13%. You can think about this way, because the last stack, you can count from the bottom. 13% for the first person to go out to handshake, and he can find 12% to handshake. That's equivalent to the last stack or last layer. And then the next person, so this is the first one. And the second person, in order to not to duplicate, because you already handshaked first one, because the first person initiate so you don't shake the first one, you're going to shake the rest of them. So basically it's equivalent to a layer of 12, 11. So basically, if you're trying to count the number of the stack from 1 to n, it's actually equivalent to like handshaking count of n plus 1 person. N plus 1 person handshake is, statistically speaking, it's just a combination number. Combination number basically is like, for 12, basically is actually is equal to yeah, so basically it's equivalent to 12. So if it's 12 stack, if it is 12 pin, let me see the pin. Yeah, 12 stranger, it's actually, it's just 12 stranger, the first one can do 11 handshake. So basically, it is 1 add to 11 equals 11 multiplied 12 divided by 2. So basically this actually is 12 choose 2, because among 12 person, you choose any 2-person group to make a handshaking effort. So that is actually statistically equivalent. So basically, we have 3 ways to view the same problem. And so these are the examples. Let me just do 1 or 2 examples. So like, you know, how many straight line will it take to connect all 5 point showing to each of the shown to each of the other 4, because those 5 points are non-collinear. So basically non-collinear. So basically it's just you choose 5, choose 2. So basically you can choose any 2 points, you will make a straight line. And that's equal to 5 multiply 4 divided by 2 multiply 1 equals actually 10. So these are quite easy problem. And the second problem, how many straight line will it take to connect 30 point if each pair point is connected by 1 line and no line pass through more than 2 point. So to connect 30 point, if you draw 30 point and each pair point is connected by 1 line, and no line pass through so basically how many line will take to connect all of them? It's like, you know, all the line, you know, and no line pass more than 2. So basically, you know, that's going to be a whole lot. So basically it's 30 choose 2. And so basically it's 30 multiply 29 and 2 multiply 1. So that's going to be 15. 15 multiply 29. So it's quite a big number. So these are the problems that come with the, you know, so just view them as a choosing problem. And then there's a counting outcomes. Counting outcome basically is the principle, is the like counting outcome usually have something to do with the fundamental counting principle. So basically the fundamental counting principle states that, you know, that one event, if you have m ways, and if you have a second event has n way, and then they are, you know, n multiply n if both events are to happen. So that's why, you know, counting problem usually end up really big number. You know, one coin is flipped because coin has head and the tail, so you have 2. 2 coin is just 2 square because each coin flip is event. Then 10 coin is actually 2 to the 10th. So that's just, you know, getting large fairly quickly. And how many possible outcomes here when one standard die is rolled at 6 and 2 dice are rolled 6 square, 2 coins are flipped and a dice is rolled. 2 coins flipped, that's 2 square, multiply a dice is roll 6. So basically that's equal to 24. It is 36. So basically, you know, that's the, yeah, so basically, you know, it's not very difficult. These are the problems that so those are not very much difficult problems. You can just go through them by yourself. Let's go to the we actually has the on the counting problems, there's a category of the problems that will be repeatedly tested in the AMC is that the number of divisor. For example, we gave you a fairly big number, like in this example, 540. How many positive integer divisor you have? And it's almost, you have to factor it and they do it so here we actually is able to factor this number down to like 2 square multiply 3 cube multiply 5. And so if we are able to factor this out to this format, it's very easy to count the number of the factors. So the way to choose two multiples, actually two exponent, is that we have 3 ways to choose two exponent. We have 0 and 1 and 2. And choose 3 exponent, we have 4 ways. We have 0, 1, 2, and 3. And 5, we had 2 ways, 0 and 1, 0 and 1. So basically 2 way, 4 way, and 3 way. So we have 24 ways to make factor of 540. So that's generically. So this is actually a proven result, because when you do MC test, you just simply don't have time to go through this type of the detail. You just have to know it beforehand. So generic speaking, how many divisor number m equals P1. P is the prime number. P1 to the E1, P2 to the E2, all the way to PK to the EK. Basically, the answer is actually you have E1 plus 1 multiply E2 plus 1 multiply all the way to EK plus 1 count of different positive factors. And yeah, so this is just, let me just do this problem really quickly. How many factor does 1 million have? 1 million is 10 to the 6 equal 2 to the 6 multiply 5 to the 6. And basically, this is prime 1, this is prime 2. So basically, the number of the prime 1, you can choose 0 of the 2 all the way to 6 of the 2. So basically, you actually have 7 way to choose. So is 5. So 7 multiply 7 equal 49. So 49 is the count of the possible positive divisor 1 million will have. And then in doing counting, we actually emphasize fairly much on a lot of like casework, because a lot of counting problem, you have to break things apart. Like this problem, how many triangle of any size are there in this figure? And so we can divide it in several ways. So one way we divide is that the little triangles, you can facing up or facing down either way. You can say in that, this is 1, 2, 3, 4, 5. So 1 plus 5 plus 5 plus 1, that's going to be 12. And the bigger triangle, like 1, 2, 3, and don't forget, there are 4, 5, and so it's actually 6 of them if you really just counting the tip sticking out. So basically 1, 2, 3, 4, 5, 6 of those. And then you have the largest one sticking out this way and sticking out this way. So basically, you can count it this way, or you can subdivide it into more specific. If you like, up facing triangle, you can find 6, and down facing 1 unit triangle, then you can find more of up facing medium-sized triangle, up facing a bigger triangle. So basically, if you do it like different way, no matter how you count it, you should always come up with 20. And so this is kind of the casework. And casework, a lot of time could get more difficult very quickly. And so basically, we have to use the method, other method to really make things easier. And like those shape counting problem, a lot of time, we actually will use the we will convert those into statistic problems. Some of the problem you actually can do that. And then we have the like factorial and permutation. And the factorial basically is saying that the n factorial is starting from m and like descending all the way to 1. So that is the factorial. And factorial has some like, special number. For example, 0 factorial equal to 1. And the 1 factorial equal to 1. So that's kind of starting point you have to remember, because those are quite unique. And factorial also have certain property, is that n factorial is actually equal to n multiply n minus 1 factorial, because this is actually quite easy to understand. And it's not just that. You actually can factor out any k number of the leading factors, still leaving the tail to be n minus k factorial. So this is used extensively to do simplification, especially you have a division, you can actually, cancel out a whole lot. And factorial problem, they do a lot of question on like, let me do some factorial problems that a little bit tricky. So for example, how many zero are there at the end of 103 factorial? 103 factorial, you will just observe the pattern is that, you basically each zero at the end of the number is related to a factor of 2 and a factor of the 5. You definitely will have more factor of the 2 in the factorial. So basically we are counting of the more scale resource, that's the factor of the 5, in determining the number of the zeros, number of the trailing zero. So basically, we know that 1 factorial all the way to 4 factorial don't have a factor of 5. 5 factorial produce just 1, and the 10 factorial until 10, you will produce 2, all the way to like 25 factorial. Basically, the first four position, 5 factorial and 15 factorial and the 20 factorial all just produce 1 of the and only until 25, 25 will produce 2 of the 5 factor. And then basically, all the way to 100 factorial. 100 factorial, only 25, 50, and 75 and 100 will produce 2 a factor of 5. So basically, by giving those pattern, we know that it's just counting off the 5 interval and counting of 25 interval. For between 1 and 103, I have 4 25 interval, and we have like 25 interval. So it's actually 20 plus 4. So 24 0 is the, is how many 0 we add at the end of the 103 factorial. So these are typical problem. Another type of problem is the keychain problem. Keychain problem is extremely confusing. Keychain basically, first you have to eliminate 2 type of symmetry. How many ways can 6 keys to be arranged on a keychain? So the way to arrange the first position of the key is actually 1, because no matter where you put it, the position is symmetric. So normally, if you have 6 keys, if you put key to hand on 6 nails on the wall horizontally, you actually 6 factorial. But arrange on the keychain, basically, it's actually starting from 5. It's 5 factorial. It's actually, in fact, 5 factorial divided by 2 and is equal to less number, so basically equal to 60. Why we divide by 2? Because you actually can flip the keychain and it could be locked the same. So basically, for example, if you say that 1, 2, 3, 4, 5, it's actually equivalent 1, 2, 3, 4, 5, 6. This range of the key is actually equivalent to 6, 5, 4, 3, 2, 1 if you flip the keychain. So basically, keychain problem. So there are 2 types of the array, the factorial problem. One is sitting on a table. Basically, you had to ignore the first factor. The degree of the factor will be reduced by 1. Then if it's a keychain problem, not only you have to reduce that, you also have to divide by 2. And then they are like, platonic shape painting, and they have even less. We'll leave those problems in the exercise. There are a bunch of those you have to be pay attention to. And then, so for a lot of factorial problem, you just have to remember canceling. So if for this problem, it's actually 25, it's very easy to understand. So this basically actually equal to 1 because the top is an expansion of 20 factorial. And then permutation is just trying to find, permutation is just trying to find the number of the arrangement in the ordered manner. So basically, permutation is highly related to factorial. Factorial, basically, it's multiply all the way to 1 because it's just multiply all the way to 1. And permutation, it could be a complete permutation. A complete permutation will be, exactly equal to factorial. But permutation, I can just do the, like, for example, 10p3, like, 10p3 is, you can read it 10 permute k or 10 permute 3, or you can 10p3. Either way, it's people know math will know what you mean. And 10 permute 3 means like, for example, if you have two true 3 candidates, or for 3 different positions, for example, president, vice president, and treasurer, then basically, it's like the first person to fill the president, we have 10 way to fill, and vice president, we have 9 way and 8. So basically, it's like a partial factorial. So basically, it's also like a, they have also another way called factorial exponent or descending exponent. So basically, each number will be decreased by 1. So for the permutation. And permutation problems usually are not very difficult. It's just, you have to be careful about those like, table arrangement and keychain. And then the factorial is very straight. Factorial is n factorial. And then m permute r is actually, n factorial divided by n minus r factorial. The reason behind it is fairly simple because you are only arranging the first few people. You are not going to arrange, you are not going to fill, for example, 10 candidates with all jobs, just 3 of them with 3 positions. And then there's a ladder arrangement. Ladder arrangement usually, ladder arrangement is a full factorial. Then ladder arrangement actually, has more variability. So for example, how to arrange algebra, because you actually have a repetition, because A and A, basically, this became a, like, it's a, like 7 permute 7 divided by 2. And so this basically, because you actually can imagine that algebra, initially you can just write 2 different case. One is uppercase, one is the lowercase. And then you treat it as if they are different. They actually have 7 factorial way to arrange algebra. But you notice that by close examination, you find that A and the capital A and the little a are exactly the same arrangement. AA and the AA are the same arrangement. So you basically have to divide by 2. So basically that's the, letter with repetitive. And so there are a bunch of exercise. And typical thing, for example, like Mississippi, and Mississippi, basically you have a lot of things. Like it actually is n factorial, k factorial, k2, all the way to, for example, let's say Mississippi. Mississippi basically have 4i and 2p and 4s, and altogether have 11 letter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 11 factorial divided by 4 factorial, divided by 4 factorial, divided by 2 factorial. So basically this is just a way to arrange the letter. And these are a lot of letter arrangement. And so letter arrangement, also there are letter arrangement with restriction. And permutation with restriction is actually, something that sometimes we actually, for example, how many even 5-digit number contains each of digit 1 through 5. And when we doing even digits, basically the last digit is at either 2 and 4. We cannot choose 1, 3, and 5. So basically we can arrange the last digit first, that's 2. Then we got 4, 3, 2, 1. So permutation with restriction, you just have to do the restriction part and trying to see what the restriction condition is doing to the multiplication factor and do it right. And this problem, for example, arrangement the restriction count in a different way that letter A and M need to be adjacent. How many of the arrangement that A and M are adjacent to each other? So in this way, we basically treat AM as a single letter. Basically, then we actually 6 factorial ways to arrange those 6 letter. Because A and M, between them, they have 2 ways to arrange it. MA or AM. So basically we had to multiply 2 factorial. So these are ways that you can do differently. And then we have the combination. We're going to finish combination today, then we'll finish today's class because we have a lot of material to cover, and we're trying to spend 3 classes on the like counting plus statistics. So because there are huge amount of the the problem to be covered. So the combination, basically what we are trying to do is work out something that order does not matter. So combination is just using a different way. For example, 10 choose 3 or 10 choose 3. And this is more popular writing. And so this is an example that there are 6 scramble letter left in a bag at the end of game. F, H, I, J, U, N, Y. If you reach grab 2, how many different pair of the letters are possible? So basically, Alexa, stop. And so in this case, basically, we still treat it as if there's no repetition, and then basically is we have 6 ways to choose the first letter, 5 ways to choose the second letter, because within 2 letter choose letters, there are 2 ways of duplication. So we divide by 2 factorial. So that actually end up with truth. And the combination, because the permutation, so combination is basically reduction of duplication upon the permutation. Permutation is ordered arrangement, and the combination is unordered arrangement. So the permutation, for example, like P and R is equal to N divided by N minus R. And then CMR is just equal to permutation and N minus R factorial. Then divide by the duplication way. So that there's a link between them. So we call N truths R. And so N truths R is just, we handle the over counting by divide by the number of the duplication. We got the combination. And we also have combination have a very important factor is the combinatorial identity is that n choose k is equal to n choose n minus k because n choose k by definition is n divided by n minus k factorial divided by k factorial. Then basically n and n minus k, n choose n minus k equal to n factorial divided by n minus k factorial. And then here is the n minus k factorial. So here, basically n factorial and k factorial and n minus k factorial. So basically, if you compare the definition of those two, if you expand the definition, basically they are equivalent same. So it's actually very easy to, this has a huge implication. So basically, if you like, for example, how do I choose like, how do I choose 10% out of 9 is actually equivalent to how many way I choose 1% out of 9, because choosing, it's very easy to understand. Choose 10%, to join an event is equivalent to choosing just one person to exclude that person to this event. So basically those are the same. And so truth saying is actually used extensively in the pass on grid. Pass on grid basically is a type of the problem that repeated testing any kind of combination test. For example, we're going to try to find how many ways are there to go from point A to point B through the grid. So we know that there are, so we can label our movement by R and U. One letter R is the instruction to move the person from east to west. And one U means, one step to move on the grid from south to north. So in order to move from A to B, we need to have total of 4R and 3U. So basically, to get different instruction to move from A to B is equivalent to how to arrange 4R and 4U. We actually convert this past problem to a later arrangement problem. Later arrangement problem of this, we already know how to do it. It's 7 factorial divided by 3 factorial and multiply 4 factorial. So this, is actually 7 through 3. It's very easy to remember, understand in another reasoning is that, because we have 7 steps to move, instead of using this later arrangement equivalence, we can just decide out of this 7 step, in which 3 positions are we supposed to move up? As long as we find out those, we fill the remaining step with just moving to right, then we complete this instruction. So basically, and there's another way of doing it. If you, so the third way of doing it is that use labeling. So how many way to, start from here and reach here? Basically, there's one way. I can only one way. So you write 1 and you can do 1. You can label either from the starting or the end point. I usually doing the reverse way. Let me just do the reverse way because I actually like to do it the other way. So how many way to go from here to here? And in the last step, in order to reach end point, we have to go from either here or here. And here, we always just one way because that's the final step. And go from here to here also one way. Go from here to here, we have two way because 1 plus 1 equals to 2. So we can just 3 and 1, this is 4 because 1 plus 3 equals to 4. And this is only one way to go from here. So here is 2 plus 3 equal 1 plus 2 equal to 3 and 2 plus 3. Oh, this is already 3. So 3 plus 3 equal to 6. And then, so basically, you can just propagate just by adding the letter. You eventually will. And this is 1 plus 3 equal to 4. So something like that. Yeah, so here comes that beyond the guesswork. So we have been trying to count how many rectangle can we form from this grid. And it's relatively easy. But how many rectangle can we form from this? For example, this is a one way to form rectangle. So basically, it's very hard to enumerate all the shapes. But there's one way that if we choose, the horizontal, we have to choose the horizontal grid in two line. They have to be on the two line, and the vertical has to be a two line. So basically, out of the 4 horizontal position, basically it's 4 choose 2. And of the 4, 1, 2, 3, 4, 5, 6, 7, on the 7 vertical position, they 7 choose 2. So that's the way, if we multiply them, because after we choose the horizontal, then we choose the vertical, we actually will get all the positions. So that is the, we are able to fix those. And yeah, I think we actually reaching a good stop point, and let's stop here, and we'll continue, and we'll send homework, and we have a lot of homework for this one, and also going to have a lot for the next two, and we hope to finish this topic in 3 sessions, and have a nice one, everyone. Bye bye.